asking for. Okay, so our host and basically Socheng takes care of PyData in the sort of the Chicago area, and she put out a sort of a call for speakers sometime last year, and asked if there's anybody who'd be interested to give a talk to the community. And that call for speakers relayed through U Chicago, our CS department. And I said, yeah, I did something that's pretty interesting and maybe useful to people who work in the intersection of Python and data and pandas. And that was last year. And then Socheng immediately responded when I reached out and said, yeah, sure, we have some time in October. Would you be interested? And I'm like, yeah, sure, absolutely. I didn't realize she said October of 2023. So this meeting was scheduled a full year in advance. And that was before I was still a PhD student at the University of Chicago. I graduated in March, and I'm now teaching faculty at the University of Chicago. So I teach Python, and I teach databases. I teach a little bit of pandas as well to people who are taking computer science, possibly people taking public policy as well. So long story short, today was an extremely busy day. This was the first thing that was scheduled last year, but then my teaching responsibilities as well as a bunch of back-to-back meetings meant that I had to make sure I, get to downtown from the Hyde Park campus and make sure that I'm here on time. So I'm glad that that kind of worked out. So for today's talk, I want to talk about a sort of like an open source project that I worked on during my PhD. It's called fuzzydata, and it's a scalable workload generator that can be used for testing any sort of workflow system that works with data frames. And this is work that I did along with my my previous my advisor, I guess, when I was a PhD student, Aaron Elmore, and he's currently a co-instructor with me for teaching introductory Python at the University of Chicago. So, without any further ado, let's talk about what database benchmarks look like, right? So the idea is databases are super useful. Everybody's using them in different types of applications. And the databases have been around for many decades, which means that database benchmarking has also been around for many decades, right? If you're talking about database systems that are basically relational database systems, RDBMSs that use some kind of traditional query engine with SQL, benchmarks have existed since the 80s. There's a long and storied history with a lot of intrigue and a lot of politics and a lot of mudslinging when it comes to database benchmarks. Long story short, Wisconsin used to be one of the leaders. I mean, it still is one of the leaders in academic research in databases. And they released something called the Wisconsin benchmark in 1983, which was used to give an apples to apples comparison between different database systems. In their initial paper, Oracle did not do very well in this benchmark, causing a lot of problems between Oracle and the University of Wisconsin. Larry Ellison very famously tried to sue the University of Wisconsin because of this benchmark, and basically threatened to never hire anybody who graduated from that university back in the 80s. But as a result, every academic database paper that is has results comparing something with a commercial system now has something called the divot clause, which means they won't name those database systems by name when they publish in these academic journals. But anyway, so relational systems have had this, right, for a while. And then the industry came together in the Transaction Processing Council, or TPC. And then they said, let's agree to a set of benchmarks that we can all kind of use to compare database systems against each other. So the Transaction Processing Council, or TPC, has a fairly standardized benchmark for all of these relational database systems. And they have many flavors or many variants of benchmarks. There's something used for traditional OLTP systems, transactional systems, and then they have something for columnar systems and data integration and so on and so forth, right? With the emergence of the cloud, one thing that happened was the entire NoSQL movement, which meant that people were moving away from relational database systems in the interest of scaling, right? So people wanted to move away from the relational database paradigm. They wanted to build simple sort of like key value stores or something that you could plug to a website front end that allowed you to very quickly get some information provided, some key. They did not want to use any sort of complex query semantics like SQL. Work from Yahoo became the main benchmarking tool for cloud for these kinds of systems, the key value store systems. It's called the Yahoo Cloud Serving Benchmark, or YCSB, and it's been standard since 2010. You can use this benchmark to benchmark any sort of key value store, from Cassandra to HBase, or any sort of product from these key value store vendors, right? NoSQL vendors. But there isn't really something good for data frame systems. And when I talk about data frame systems, I'm talking about pandas, right? Any sort of system in which you're working with data frames and not database tables, where you might have sort of semi-structured data, maybe possibly multidimensional, but there is some kind of spreadsheet style ordering of the data that you have. So what makes these data frames different from relational database systems, right? So data frames allow you to mix semantics across sort of relational spreadsheet style operations. You can represent things like matrices or relational tables or spreadsheet data into a data frame object, and it allows you to issue queries that may, usually you can express them in SQL, but there's also these kinds of operations that are not as easy to do in SQL, like pivots, for example, which are easy for spreadsheets to do. But in the process of preparing data for machine learning pipelines, people find tools like pandas to be much more useful to operate with these data frames. And the basic history of data frames, it kind of started from statistics. There was a special purpose language called S that came out in 1976, similar to relational tables, but they allowed for operations on large matrices. Then the R programming language became popular and was open source. Basically, took the semantics of S and data frames. Came out in around 1993. So the S language is essentially open sourced by R. But the real moment for data frames kind of came from computational finance and Wes McKinney, who introduced the Pandas project in 2008. So he liked the data frame semantics in the R programming language, but he also wanted to bring in the power of Python to write sort of custom Pythonic code to operate on these data frames. So using NumPy as a backend, he basically developed the Pandas package, which allowed you to sort of use those R-style semantics to operate on, to define and operate data frames in Python, right? And then you can say that that was kind of the sort of the moment where data frames kind of exploded in popularity and went beyond just people who are in statistics, right? So machine learning engineers and so on and so forth kind of found a neat language where they can marry both sort of like the data frame, sort of mode of operation, right? The data frame semantics, but with the power of this expanding universe of Python projects, most of which actually come from, basically supported by NumFOCUS right now. So the core, numerical and scientific Python libraries that are available, NumPy, SciPy, and so on. And the combination of all of this and the fact that all of the data was interoperable between all of these libraries made pandas extremely popular, right? So we have the Google Trends graph, something you'd see in a lot of these presentations talking about how things are super popular. But what has happened recently is people are trying to crunch larger and larger data sets on pandas. And that, because of the way pandas was written using a NumPy backend, there are scaling bottlenecks that prevent pandas from being used effectively in sort of these cluster environments or distributed computing environments where you may not have a shared memory available to multiple processors. And because of that, now we have a whole zoo of pandas or data frame related projects that try to scale pandas out into multiple sort of distributed computing environments, right? So if you had a cluster, you could try to process your data using Spark. If you have a lot of cores on your laptop, maybe there's some other engines, execution engines that you could use to try to scale your data frame processing. And this is for millions of data frames that have millions of rows or possibly millions of columns, right? Depending on how things are structured. So, and because of this, like performance evaluation of data frame systems is not something that we see to the caliber for what we have with traditional relational database systems or key value stores. Mostly what you're going to depend on is anecdotal evidence from people who use these systems, right? So someone might tell you, hey, use Modin or use PonderData or use Spark. And if you have a job that requires you to process millions of rows in a data frame, you will get X amount of speed up if you throw it into the system, right? So mostly we just have to go by these vendors on their word that we wrote a high performance query engine. It's much faster than pandas, and it'll help you out, right? So usually if you visit so Modin, for those of you who don't know, is a drop-in replacement for pandas that is supposed to use an execution engine like Ray or Dask in the backend and automatically speed up anything that you were trying to run on pandas. So you could, instead of saying import pandas as PD in the top of your Python program, you can say import modin.pandas as PD. And then you can sort of just reuse your entire Python program by just changing one import. So that's what the Modin project is essentially selling. And then what they kind of say is, because they have a distributed execution engine beneath, common data frame operations like read CSV or checking if a certain data frame is null, or if you want to apply a map operation to everything in a data frame, you'll get X amount of speed up, right? But in reality, if you kind of visit the Modin issue page on GitHub, you're going to see a lot of people saying, hey, I was sold this promise that if I just replace one line, I will get immediate speed up. The truth is, not all operations are parallelized. There are operations that will take time, and then the Modin has sort of essentially an army of engineers. I would say they're a successful startup because Ponder just sold yesterday. PonderData is the organization, the company that was built around Modin. They just sold yesterday to Snowflake. So that exit is kind of over. But the open source project has been pretty successful. A lot of code contributions into Modin. But you will see a lot of these issues saying, hey, I'm trying this pandas operation, it's running too slow. What is happening, right? And then there aren't really any good benchmarks for pandas right now, right? So there are some benchmarks that have very limited coverage. Usually they use a single data type. Maybe they just create a data frame full of integers, and then they run some typical operations that take time to do. So there's an evaluation only of relational operations for these systems, right? So the most famous one, if you kind of Google data frame benchmark, you will get your top hit is going to be something from h2o.ai, which is an automatically running comparison of data frame engines for set queries, right? So if you visit their website, it gets updated, I think, automatically. There's a nice cool script that basically says, run this one operation over some synthetic data and measure the time taken by different data frame libraries, right? And it's called the database like ops benchmark from h2o.ai. And notice that they only have 3 different tasks with this one group by, one join, and another type of group by that was changed in 2014 for some reason. And then they have 3 scaling factors, which is 5 gig, 0.5 gigs, 5 gigs, and 50 GB, right? So again, I would consider this also to be very specific, a very specific type of benchmark that is taking a specific operation and then saying, how does this run over different query engines? It's a good start, but we need more realistic ways of benchmarking data frame systems, right? So what I would like to posit is the ability to generate a workload that is indicative of what people typically do on pandas with data frames, right? So the first thing I want to say is, instead of just having data frames that are filled with integer values, they need to have realistic data types. So you can have strings of arbitrary length. You could have a wide variety in the types of data that you represent in data frames, right? So we want sort of realistic values. I'm not sure if that's necessarily visible, but we might have fields like country, or maybe a large blob of text, or floats and things like that. The second thing I want to also mention is we want to try to generate workflows that have different structures, right? So there are different data analysis patterns. Sometimes you might have a linear pattern where you start with the data frame and then you sort of modify it in different ways in order for you to get a certain subset of that data frame, which we then may send to a machine learning model for training. Those are linear workflows, but sometimes you might have multiple machine learning engineers who are trying different feature engineering ideas. So they might branch their data set into multiple branching patterns, or somebody's working on some fresh data and they throw a lot of engineers at the project, and then you basically have a star-like representation of what your workflow is, right? Like, so multiple people working on multiple samples of the data, for example. So we want to try to build a system where we are able to do all of this, right? So the system that I built as part of my PhD is called fuzzydata. It's a workload generation tool that is programmable and allows you to sort of automatically generate data frame workflows, right? So the idea is you should be able to take a typical data frame workflow. Maybe you have a Parquet file and a CSV file that you've decided to load, and then you merge them into a single data frame based on some key. And then maybe you do some kind of row filtering followed by a pivot, and then you get a data frame that is useful for you to then pass on to a machine learning system, right? So we've abstracted the notion of this by calling this a fuzzy data workflow. And then we have abstractions for each of these artifacts. The fuzzy data artifacts are just an abstract representation of a table. It contains the metadata or the schema of the table, as well as serialization and deserialization routines. We also have abstract representations of these common operations that people like to do. So they're both relational operations as well as operations that you might do in pandas. Currently, it's a small subset of operations, but we would like to grow this over time, right? Pandas has hundreds of different operations that you can do on data frames. So we want to have an abstract representation of these operations, how the arguments are specified, and then how we expect the schema of the data frame to change when we apply this operation. So all of this is abstracted into fuzzy data. And what we can do now is we can give an abstract specification of a workflow as well as some input files. And what fuzzy data gives you now, and then we also specify the workflow itself, right? So a list of operations, source artifacts, and maybe enough information that allow you to scale the data frames up and down if and when required. Once we have all of this defined, and we define these in JSON files with a bunch of input artifacts, a JSON file, a set of operations, we can describe the entire workflow in a library agnostic manner. What fuzzy data can do is can take that JSON specification and those files, and it can generate the individual workflows for each of these systems. So using a fuzzy data workflow specification, you could say, hey, generate a pandas workflow, and it'll actually generate the Python code for the pandas workflow. It can generate the Modin workflow, where it's basically the pandas workflow, but the import was changed to Modin. But more importantly, it can also generate the equivalent SQL expressions for this workflow, as long as these operations are supported. So right now, this is what fuzzy data looks like, right? Given some abstract workflow specification, we can generate all of these different code for all of these different systems, and we can run them, and then we can kind of time how long it takes to finish executing the workflow. I'll kind of pause here for a second because I talked quite a bit. And if anybody has sort of questions or comments at this point, you can let me know. Otherwise, what I can do is I can sort of keep going, right? So that's what this project is essentially, right? And the other thing that I'm leveraging is the ability to generate truly random data frames that have realistic values. And there's a very cool library in Python called Faker. Faker allows you to generate any sort of like fake data. So you could ask it to generate fake names. It'll actually generate strings that are like first name, last name. You can generate fake SSNs. You can generate fake telephone numbers. And the best part about Faker is you can set a locale. So you could say maybe Hindi, India, and it'll generate fake Hindi names, fake Hindi locations, fake Hindi addresses. It's a great tool, especially for those who are doing sort of web testing and maybe form input validation, and they want to do localization for different areas. And that's the main use of Faker, right? So what the ability, the great thing about Faker is I can tell it to generate a 5-table data frame. I mean, this is Faker doesn't generate data frames. fuzzydata does, but Faker will generate those individual values inside. So give me random dates formatted in ISO 8601, or give me random cryptocurrency codes, and then Faker will just generate those, and then I can generate a whole data frame out of it, right? So give me integers or give me random numbers. Those are fairly easy to generate, but it can also get random US addresses. Hopefully, I don't think they're valid addresses, but yeah. And then the idea now is I can now generate these realistic data sets with varied data types, and I can vary between string, numeric, datetime, and etc. What fuzzydata does is internally it keeps a taxonomy of each of these column types to say that some of these types are groupable. So I could do a group by operation on some of these columns. Some of them are unique enough that I could use them as a join key. So I keep that information so that I can generate a whole set of operations that I want to use this with. In the future, and again, part of this talk is to see if people are interested and if they would like to contribute to this project. Some ideas that I was thinking about is maybe generate data that has functional dependencies. So you generate name SSN pairs so that if a name and SSN appears, it always appears in the same sequence. That's a database functional dependency. Or if you want to enforce a certain amount of cardinality, like you want to generate a huge data frame that has 1 billion rows, and you are about to do a group by on one of the columns. So you want a fixed cardinality. Maybe 1 billion collapses down to 1,000 rows. So that's what I mean by enforced cardinalities in some of these columns. So the operations that I encode in fuzzydata, basically what I'm doing is I have the entire system allows us to encode the operational semantics, and it basically is a way for us to describe that if you need to do a group by, you need at least one groupable column, maybe one column on which you can do some sort of aggregation. And then after the group by, this is the expected schema transformation that will happen when you apply this. We want to do this in as broad of a manner as possible so that you can finally generate the code for those individual data frame systems like pandas and modin and so on and so forth, right? So, but the actual implementation of this operation is now left to the client, right? So we write these clients for pandas, for modin, for SQLite, and what we do is we actually implement this operation in those clients. And then finally, a workflow is something that we can so fuzzydata has the ability to generate absolutely random workflows, or you can provide a JSON specification of a workflow. And what you can do now is you can automatically use fuzzydata to generate the actual code for the individual libraries. And all the specifications are in JSON, so that makes it human readable, editable. You can encode your own workflow. So if you'd like to, if your company is deciding what data frame system I need to use, they can take a typical workflow, encode it using fuzzydata, and then just run it across different systems to kind of use the inbuilt code generator to see what the difference is, right? Yeah, all right. And then one sort of, again, whenever I say future work, this is me putting my PhD hat on, because this is what I had to convince my sort of advisors and committee about, like, these are the future directions. But these are also things that if people find this tool useful, there are avenues for contribution, right? So one thing that, if you're a language expert or a Python expert, there's a possibility of taking a Jupyter notebook and then automatically extracting this workflow specification out of it, right? using basically programming language, PL sort of things that you can do in programming language, or inspecting the abstract syntax tree and so on and so forth. So what our system does, there's a little bit of math in the slide, but basically these are the parameters that we can pass into fuzzy data. We can generate a workflow that has 100 different artifacts, for example, and the initial data frame that you generate needs to have at least R rows and C columns. I have a way of controlling the linearity of this workflow by using something called a branching factor. There's some complex math. I had a physics roommate who came up with this really neat way of saying, how linear do you want your workflow to be versus how branched out you want your workflow to be. So we can plug in a number there and we can basically generate any sort of pattern of workflow that we want, right? And so currently I've written 3 clients for fuzzy data. There's a pandas client and a modern client. So if my abstract data representation is like I'm going from data frame 1 to data frame 2 by sampling 100 rows, then my fuzzy data will automatically generate the pandas code for that, right? Like df1.sample n equals 100. But you can take the same specification and you can say generate the SQL for this. And it would say create view D2 as select star from D1 order by random limit 100, right? So you can, that's the SQL way of taking 100 samples from a table, right? So currently all of these operations are implemented in fuzzy data, right? We can load data frames, we can do a select operation on some kind of filter condition. We can create a new column by applying some function. We can project a set of columns. We can sample rows. We can join 2 data frames based on a common key. We can pivot, but you can only pivot in pandas and mode in SQL. SQLite for now doesn't support pivot operations, but you could write maybe a client for MS SQL or some other commercial SQL system that actually supports pivoting operations. You can also group by. So some operations like fill, they're pretty common in pandas, right? Like you have a null value or a 0 value and you want to fill everything in the column with something else and so on, right? And basically these are all the client operations that we support, right? So the main thing that I'd like to sort of pitch fuzzy data for use is, if you're currently writing a data frame based system, you can use this for fuzzy correctness checking. So this is literally a random workflow generator, and you can use it to just run and generate hundreds of artifacts and run hundreds of operations and use it as a way for testing whether your data frame engine actually works or not, right? And in fact, that's kind of what we used fuzzy data for, right? So we used it to basically run against sort of the daily snapshots of Modin and try to find bugs that were introduced by somebody changing the Modin code base. We were able to find at least 2 or 3 major bugs. This was as of last year. We found a bug in Modin where if you loaded a data frame from a disk and then you applied 2 different group bys, this was okay in Modin. But if you generate a data frame in memory and apply those group bys, then that group by does not work in Modin. This was an issue that we surfaced and then got them to fix through this tool. So as a result of this, and then I reached out to them and I said, hey, this is a problem. Maybe you want to look at this. And then they promptly issued a bug fix. They got it fixed. Now, what has happened since then is fuzzy data is now part of the continuous integration suite of Modin right now. So it's basically sitting and running, randomly generating data frames. And for every new release of Modin, there will be some tests that run using fuzzy data to see if there are mistakes, right? The other great thing is, like I mentioned, you can take a fuzzy data encoded workflow and you can run it across different systems and compare the results to make sure that they're doing the right thing. And what you can do is you can take an existing workflow, encode it into JSON spec, and then run it over different systems and get a performance result, right? So Modin's demo was a NYC cab demo where they take a huge NYC taxi data set and then they group by, maybe I don't remember exactly what they did, but they group by certain parameters, maybe time of day and things like that. They run it on pandas, Modin using 2 different backends and SQLite. And this is one of their main things that they wanted to promote was how fast Modin is compared to pandas and how fast it is. Well, they don't compare to SQLite, but we are able to because of fuzzy data, right? So this looks like this is great. Like Modin is like 4 times faster to run this particular scheme. And in fact, this was used to validate their claims as well, right? So they claimed it is 4 times faster. I took it into fuzzy data, generated all the code for this, ran it, and we were able to sort of verify that it was 4 times faster. The other thing you could do is you could take a workflow and then scale all the artifacts up. So you could say, this workflow has these data frames that are maybe 100 rows. Let me scale that up to 1,000,000 rows and see what happens. That's another thing that you could do with fuzzy data. So that's a great way to sort of explore that a workflow that worked on a sample of the data should also work on the entire data or the entire data set, and you can verify whether it actually runs and how much time it takes to do this scaling, right? So what we did was I generated a random workflow in fuzzy data. We started from some artifact. And then what we did was we basically ran multiple sample operations and multiple group bys, multiple projection operations. So from starting from a basic data set, we generated 11 different data frames from it by running different operations using a weird branching factor. And what I did was I took this very same workflow and I scaled it from 1,000 rows all the way to 5 million rows. And now you can sort of see how different data frame engines are scaling. And this is a case where pandas beats Modin, right? Modin was not optimized enough to do fast random sampling in a distributed fashion. Because of all of the sampling operations that are happening here, now Modin's not doing so well, right? So again, this is another case where there are operations where Modin's not fast. And they admit it as well, right? It's a work in progress. They're still working on this. This was as of last year. I haven't had time to rerun this workflow, so we'd have to see how things go now these days, right? Fuzzy data is completely open source. It's available on GitHub. You can pip install and you can play around with this. So you could just say pip install fuzzy data and then say create a pandas workflow that has you're starting with a data frame that has 10,000 rows and 20 columns, and create 20 versions, like run random operations and create 20 different data frames from that that initial data frame. And then you can take that data frame that you generated and then you could replay it on a different client, right? So replay it on Modin and then see what this was, right? So for those who are working on open source projects, especially if you're working on these alone, if you would like to get your project to be pretty popular, so this is the fuzzy data repository on GitHub, and if you visit the PyP page, it's now like at 300,000 downloads, right? That is not 300,000 organic downloads. I don't have 300,000 developers who are working with this. This is all from the Modin CI pipeline. So every time there's a new version or a new nightly build of the Modin system, it just pulls the latest version of fuzzy data and runs it against their code base. But if you'd like to get a high download count for your project, that's, I think, one of my suggestions is try to integrate it into a big project CI pipeline, and you won't get stars, but you will get like a lot of downloads for your project if you wanted to. So yeah, there are a lot of things I wanted to do with this project, but again, since I've now sort of transitioned to full-time teaching at U Chicago, I haven't really gotten the time. But some work that's fairly easy to do is to write additional clients for this, right? You could try writing a Polars client or a Rapids client or a DuckDB client, right? DuckDB is super popular now as a system that does sort of data frame like they're trying to be the SQLite for analytics. So because they use an extremely fast query engine and things like that, right? We also talked about making more realistic data frames, like generating realistic functional dependencies and so on and so forth, right? But that's, I'm trying to reach out to more people who use things like this. So maybe it's possible that at least it's in a state where it's a public project on PyPy, and you can basically just pip install and play around with it. For folks who are doing any sort of research on data frames, it's possibly a good tool that you can use to try different things with with data frame engines like pandas and so on and so forth, right? So yeah, basically what the reason for this talk is essentially to kind of convince you that existing benchmarks are not great. Anecdotal evidence is also not great when you are in a decision role for your company, or you're an engineer for a company that is working heavily with data frames, and your CTO or somebody comes to you and says, what data frame engine should we use because pandas is not scaling fast enough. You're going to see a lot of marketing material from different companies, and they may or may not necessarily be true. I won't claim that fuzzy data is like the one-stop solution where you just go and you can plop in your workflow and try to get answers, but it's a step in that direction, right? We want to try to make more industry standard benchmarks for these kinds of systems. And we were able to use it as a fuzzy correctness check. And at some point, I would like to maybe get the community around building an actual data frame benchmark, right? Encode some more realistic workflows and use it to compare different data frame systems, because there's an explosion of these data frame systems. Thanks for coming to my talk. I'm Suhail, right? I'm available on suhailrahman.com. And yes, please, if you find this interesting at all, please visit Fuzzy Data's GitHub page, and you can check out ways in which you can contribute or try out the project if you're working with sort of these data frame systems. All right. Thank you very much. Hopefully the talk was accessible. I kind of went in like a big rant about data frames, but if you guys have any sort of questions or comments about this stuff, or any sort of experiences that you guys have with pandas, you guys can let me know. Pandas or any sort of data frame engine for that matter. Oh, yes.
Great work. So it's a great work, and I'm going to give you a star on GitHub, like after going home. Like in general, right? Like when we build machine learning pipelines or something, the data pipeline that we build at starting like matters a lot, right? So with this fuzzy data, there is a lot of scope that we can create different kinds of pipelines. So often we like, even somebody's doing a data architecture, like architecture, solution architecture. So they go with like, okay, we are getting this much amount of data. So we'll be using this pipeline to get the model better, like the efficiency or like the scalability, whatever. So now with the fuzzy data, we can do multiple iterations. So there is the fake generation part that we have. And you are creating DAGs, like a different workflows. So we can always experiment more with the fuzzy data, and then can build better systems. And now, like if somebody asks, like the CTO or someone, we can show, okay, I have experimented enough. So this pipeline or the workflow is better for our solution. So it would be very great work.
Yeah, I mean, the intention behind this work was, this was auxiliary work for other things that I was doing in my PhD, which was I was working on something called lineage inference. If you have a bunch of these random CSV files that are sitting in a data repository, is there a way you can connect them with each other without looking at the code, right? So one thing I needed was the ability to generate very randomized workflows, and this fuzzy data is something that came out of that. Absolutely. Yeah, and just yes.
Like a SPSS, SAS, or Excel for fuzzy data?
Yeah, so that's another great question, right? So what about things like SPSS? So one of the things we can do is any application that can export to CSV file, right? You can use that as an input into fuzzy data if you want to. So if you were working on an Excel spreadsheet or possibly SPS, I'm not entirely sure about SPSS, but if you're working on an Excel spreadsheet, you can save it out as a CSV file, and we should be able to bring it into fuzzy data, and then we can basically ask it to just try to randomly generate operations if you want to, right? It's not super easy if you've not generated the data using Faker, but at least you can give the specification, a workflow specification starting from that data. Yeah. It's independent. It's independent. It's not supported necessarily by any sort of like, and the only integration it has right now is it's part of modern CI pipeline, but it's not, it is installable, right? It's available as a Python package. You should be able to install it on pretty much any machine if you want to try it out. So that's the current situation. Yeah, any other? This whole thing is in Python. It's all Python. Or everything's written in Python, right? So yeah. And then the SQL generation is just code generation that's happening inside Python itself. Yeah. Yeah, pretty much you can use it on any sort of Linux environment. You should be able to pip install and try it out, right? So it should work. All right. If any other sort of questions, comments. All right. Thanks again for coming to the talk. This is fun. It's nice to again reach out to people in the Chicago community and online as well. And if anybody else wants to say a few things, or we could just end there. Yeah. All right. Thank you, everyone.